All right. Hello, everyone. Can you hear me okay? Hello, hello. Well, so nice to see everyone here. And in the chat, as you may have noticed, everyone's introducing themselves and where they're from in the world. I'm seeing Malaysia and Canada and Brazil and India, Philippines, Vietnam, Taiwan, Ecuador, Singapore, New York City, and beyond. So nice to see so many faces and names from around the world. Please feel free to connect with others via that window. Welcome as well to the many participants in this year's New Year's seminars. This is the third of CS50 seminars. This one's on an operating system known as Linux. The first two, of course, were on Python and SQL. And we've got one more coming up this week on game development. And a special thanks to all of our mentors who have wonderfully volunteered over the past few weeks to help answer questions in Zoom chat, as well as in Ed, the course's Q&A platform. So if you have any trouble today with questions, or if you fall behind, have technical difficulties, truly not to worry. Do try to ask your questions in the chat window here or on Ed online, or all of today's materials, including the recording, will be available on the course's website as well. Before we begin, as some of you know, we have this tradition of taking a group photo of sorts. If you would like to participate, please go ahead and turn on your camera at this moment. And in just a second, we'll all start to take screenshots on our end to compose them into one big photo. So here we go. If you'd like to go ahead and put on your best smile, whether it's late in the eve or early in the morning, wherever you are, feel free to wave as well. And what our colleagues behind the scenes, Arturo and Valerie, are doing right now is paging through the 100 plus of us who have our cameras on, taking screenshots so as to compose them later. And Arturo, was that you?
We all said thank you.
Oh, and Rongshin is now with us as well. Thank you. Well, without further ado, allow me to introduce tonight's teacher, CS50's own Kareem Zidane. We first met Kareem some years ago online. He was a student and had taken CS50 itself online, and was then participating in CS50's Facebook group, answering questions of classmates and generally being an amazing resource for folks. He then ended up here in Cambridge, Massachusetts for the past few years, working with CS50's team full-time, and in particular working on CS50 IDE, the integrated development environment that you're about to use, as well as on so many more of CS50's own projects. So you are in very good hands today with CS50's own Kareem.
Well, thank you so much, David. Hello, everyone. Good to see everyone here today, and welcome to A Taste of Linux. My name is Kareem, and in this seminar, we are going to introduce Linux and the Linux command line, and we're going to scratch the surface of quite a few tools that should be useful if you decided to take CS50 in the future, or even beyond that. If you've never used Linux or the Linux command line before, don't worry, we'll start from the beginning. But at any point during the seminar, if you have any questions, definitely feel free to ask in the chat window or on the Ed discussion forum at cs50.ly/ed. Now, let me go ahead and start by sharing my slides here. All right, can everyone see my slides? Okay. All right, awesome. So the goal from today's seminar is not by any means to try and memorize everything that you'll see today, but rather to get some exposure to some of the ideas and some of the tools that exist and get a sense of what's possible. And one thing I'll mention is when I started using Linux a few years ago as my main operating system, that I was not comfortable at all using Linux or the command line for that matter. And one thing that I found to be very useful is that I just simply looked stuff up as I needed to. And I still do this to this day. Over time and lots of practice, I just start knowing things off the top of my head. And a lot of these tasks become easier for me as well. Now, before we dive into today's topics, I wanted to share a few links with you for this seminar. If you'd like to get access to these slides, you can go ahead and visit cs50.ly/seminars/Linux, and that will give you access to the slides as well as all the links that are inside the slides. So you can click on these links or copy and paste them if you'd like to open them or take a note of them without having to type them out. If you don't have a GitHub account, please go ahead and visit github.com/join to create a GitHub account. You will be using your GitHub account to log into some of the CS50 tools that we have. And the tool that we'll be using today is called CS50 IDE, which is a cloud-based programming environment that lives at ide.cs50.io. So you're going to log into this tool using your GitHub account, and we're going to be using this tool for today. We're going to be demonstrating quite a few commands today. So if you find yourself falling behind on some of them, or you just want to look something up later, you can go ahead and visit cs50.ly/seminars/Linux/commands, and that will give you access to a Google document that has pretty much all of the commands that we're going to be using today during this seminar. And then finally, once again, if you have any questions during this seminar, definitely feel free to ask in the chat or on the Ed discussion forum at cs50.ly/seminars/ed. So thanks to David. He's pasting all of these links in the chat right now. All right, cool. Now, let's get started. What is Linux? Most of us probably use some sort of operating system on their desktops and laptops, like macOS and Windows. Linux is yet another operating system that is free and open source. Now, even though most people don't use Linux as their main operating system, Linux is still pretty much everywhere. It's on smartphones, on cars, on home appliances, on servers, and supercomputers, and so many more. Linux is also used by so many software developers and system administrators in the industry, which is one of the main reasons why we are talking about it today. Now, many companies, organizations, and communities take advantage of the fact that Linux is open source and create their own customized version of Linux, also known as Linux flavors, Linux distributions, or Linux distros for short. Some examples of these include Debian-based Linux like Debian itself and Ubuntu, RPM-based Linux like CentOS and Fedora, Pacman-based Linux like Arch, but there's so many more. Debian, RPM, and Pacman refer to the format of the software packages that you can download and install on these respective distributions, respectively. So one of the key differences that you're going to find between these different distributions is how you install software on each of them, but they still share the core part of the operating system, so there's so much in common between them as well. All right. Now, just like macOS and Windows, Linux has its own graphical user interface, or GUI for short, where we interact with the system using our mouse and a keyboard. For example, we click on things to select them. We double click on things to open them up. We drag and drop things to move them around. We have all of these menus and all of these buttons that we can click on and interact with. So this is what is known as a graphical user interface, or a GUI. But most of us already know how to use a GUI. So today we're going to use a different way to interact with the system, and that is the command line. So what is the command line? It's a way of interacting with the system using textual commands. So just by using my keyboard, I will be able to type down some commands and run these commands to achieve different tasks. And we'll see some examples of that. Now, all of these operating systems, including macOS and Windows, have some sort of command line, although it might be called something different on each one. But why, you might be wondering, why would we use something like the command line and type all of these textual commands instead of using the GUI, which is arguably more user-friendly in some cases? And there's many reasons for that, but one of the main reasons why is that using the command line is going to be more efficient and more powerful in some cases, allowing us to do things that cannot be done easily using the GUI or cannot be done at all, allowing us to have this extra level of granularity of what we can do as well. So before we dive into the Linux file system hierarchy, any questions on any of the concepts that we introduced so far? Sonia is asking, can anyone explain distros? Distros are just simply customized versions of Linux that are available. So Linux is open source. Anyone can take a source code for Linux and customize it however they want. And so some companies and organizations and communities take advantage of that and create their own custom versions of Linux. These are called distros. Good question. Is there any performance difference between these distributions? Probably yes. You will find some performance differences between distributions depending on, how customized it is and, what's installed on it and so on. Is there a Linux laptop or is the OS installed on any computer you have? So Linux can be installed on any PCs. I believe Linux can be installed on macOS as well. But something that we'll talk about today later is that we can install Linux inside of a virtual machine and use this within our computer no matter what operating system we're using. All right, good question so far. Now, let's dive into the Linux file system hierarchy, or in other words, how the files and folders are laid out in a typical Linux system, just so we know or get a better idea of how we can navigate the system. And it's pretty easy in Linux. Everything in Linux lives inside of one folder or directory called the root folder or slash. So inside of the root folder or slash, we are going to find some more folder, for example, etc, home, user, opt, and more. And maybe we'll find some more files. Inside of each of these folders, we're going to find some more folders and more files, and so on. So we end up with this sort of tree-shaped hierarchy for the file system where everything lives inside of one folder, the root folder, and then we have a bunch of nested folders, and then maybe some files as well. Now, it's often the case that we need to refer to the location of one of these files or folders on the tree, and for that, we use what is called a path. So a path consists of names of directories leading up to a particular file or directory and separated by a slash. And there's two kinds of paths. There's what is known as an absolute path that starts all the way at the top of the tree from the root folder or slash. And it doesn't matter where we are in the system, the absolute path for the same file or folder stays the same so long as the location stays the same. And there's what is known as a relative path. Relative, meaning relative to the folders that we're in right now. All right, so let's see some examples of that just to make more sense of it. Suppose we have this file tree here, and we'd like to refer to the file called mario.c near the bottom of the tree, highlighted in yellow here, using the absolute path. What is the absolute path of mario.c? Now, once again, the absolute path starts all the way at the top of the tree. So we'll start all the way at the top with the root folder slash, then we'll pass by home, Ubuntu, pset1, and then finally mario.c. So the absolute path for this file ends up being something like /home/ubuntu /pset1/mario.c. The very first slash represents the root folder, and then every slash after this is just a separator between the folder names on the path up to mario.c. All right, so let's see another example of an absolute path. What is the absolute path of the pset0 folder highlighted in yellow on this file tree? Again, the absolute path starts all the way at the top of the tree. So we start with the root folder slash, then we pass by home, Ubuntu, and then finally pset0. So the absolute path ends up being something like /home /ubuntu /pset0. Let me pause here for a few seconds and see if we have any questions on paths or the absolute path so far. Can we make our own distros? It's going to be a bit complicated, but in theory, yes, you can make your own distros. Why does root and the slash separator the same? The answer to that is that that's just how they decided to do it. I understand it might be a bit confusing, but they just decided that it's going to be called, the root folder is going to be called slash, and the separator is also going to be slash for some reason. All right, how to run Linux, Ubuntu, and Windows after installing it. We are going to give you a link at the end that explains one way to do this. All right, let's move on. So this was the absolute paths. Let's take some examples for relative paths. So what is the relative path of the file called mario.c highlighted in yellow? Now, we can't just say what is the what is the relative path of mario.c. We have to say what is the relative path of mario.c from the folder that we're in right now. So suppose the folder that we're in right now is the one highlighted in orange called Ubuntu. Because again, a relative path is relative to the folder that we're in right now. So what is the relative path of mario.c from Ubuntu? Now, with a relative path, we do not need to start all the way at the top of the tree. So we just say pset1 / mario.c. So starting from Ubuntu, we go to pset1 and then mario.c. This is what the relative path would be. Now, this also happens to be the same as /pset1 / mario.c. Dot meaning start from the current directory or folder. So again, folder and directory are the same thing in Linux. So dot means start from the current directory, which is Ubuntu, then go to pset1, then go to mario.c. So the relative path could be /pset1 / mario.c. Let's take a bit trickier example here. What is the relative path of mario.c from pset0? Now, we can't just say pset1 / mario.c in this case because there is no pset1 folder inside of the pset0 folder. We have to go back up one folder to the parent folder, Ubuntu in this case, then go back down to pset1 and then mario.c. So this notion of going up to the parent folder is represented using ... So dot represents the current folder, ... represents the parent folder, in this case, Ubuntu, the parent folder for the pset0 folder. Then we go to pset1, so ... /pset1 / mario.c. And so the relative path of mario.c from pset0 ends up being something like ... /pset1 / mario.c. So this was relative paths. Any questions on absolute or relative paths anymore so far? What if there are two folders with the same name? So you can't have two folders with the same name in the same folder. This is not going to make sense for us, for our purposes. So folder names have to be different if they are in the same folder. But you can obviously have folders with the same names in different folders, in which case the paths will be different. Can you also use the command cd? We are going to talk about cd in a moment. We are just talking about referring to the locations of these folders and files right now, so using paths. But we are going to use that with some commands, including cd. Are they always lowercase? No, they don't have to be lowercase. They can be uppercase, but the example that I have here only includes lowercase names. But yes, Linux is case sensitive. So a folder called pset1 with all lowercase is different from a folder called pset1 all uppercase, for example. That's a good point as well. Yes, names, file names, and folder names in Linux are case sensitive. All right. So let's move on. So again, dot means the current folder, dot means the parent folder. But let's demo some commands now. So I'm going to move to my CS50 IDE at ide.cs50.io. So if you'd like to follow along, please go ahead and visit this URL. And this IDE is a cloud-based programming environment, which means it's a programming environment that lives somewhere in the cloud or somewhere in the internet, and it's isolated. So we can experiment with it however we want without worrying about breaking anything on our own Macs or PCs. So this is one of the nice things about CS50 IDE or any isolated environment like it. This CS50 IDE is running a distribution of Linux called Ubuntu Linux, one of the very popular ones. And the first thing that you'll notice once you visit ide.cs50.io and log in is that the CS50 IDE has a GUI of its own, or graphical user interface of its own. This is completely separate, completely different from what a standard Linux GUI looks like. This is just the GUI for the CS50 IDE itself. And down here at the bottom, you'll see this blue window that we're going to call a terminal window. So this is where we'll be spending most of our time today. So let me go ahead and maximize this by clicking the maximize button. And now I have this full screen, totally in focus, great. So let's start by defining what is a terminal. A terminal is simply a program that runs another type of program called a shell. All right, so what is a shell? A shell is a program that simply waits for a command, processes this command, and then runs it. And there's many shell programs that exist. One of the most popular ones is called bash, and this is the one that we'll be using for today. So we have our bash shell running inside of our terminal window right here in the CS50 IDE. Any questions on what a terminal, shell, or bash mean? Why is there a $? We're going to talk about this right now. Can I run bash on Windows? Yes, you can run bash on Windows. What is a shell? A shell is a program that runs inside of a terminal window, for example, that waits for commands, processes these commands, and runs them. And bash is an example of a shell program. So there's many shell programs available. Bash is just one of them. So bash is a shell. It's one of the most popular ones. Is that the same as CMD from Windows or PowerShell from Windows? Yes, the concepts are very similar. However, PowerShell is a different shell on Windows. So the syntax might be different a little bit. Is bash only available on Linux? No, bash is available on macOS as well, and it's available on Windows too. All right, good questions so far. Now, the first thing that you'll notice in this terminal window is that this little tilde / $sign here. We'll get back to what tilde means, but this is known as the shell prompt. And this is where we'll be typing our commands for today. And this can be customized. In the CS50 IDE, it just happens to be customized or configured to be the path of the folder that I'm in right now. So apparently I'm in a folder called tilde right now, but we'll get back to what that means in a moment. The $sign here is just a separator by convention that separates the shell prompt from the command that I'm going to be typing. So this is what the shell prompt is. And the first thing that I'm going to do is, let's go ahead and go to the root folder /. So for this, I'm going to use a command called cd or change directory space, and in the path to the directory that I'd like to change directory to, which is / in this case. So cd space / will take me to the root folder, enter. And then you'll notice here that the shell prompt changed. So this is now showing /, indicating that I'm now in my root folder. And the first question that I'm going to ask you is, what do you think is going to happen if I try to go up one folder? You can't, nothing, error, stays there. All right, all good guesses. Let's go ahead and try and do this. So cd space, and then how do I go up one folder? What symbol represents the parent folder? ... That is correct. So if I do cd space ... to try and go to the parent folder, enter, nothing seems to be happening. So we stayed at /, we stayed at the root folder. And this is because, again, / or root is the topmost folder in our file tree, so we cannot go any more up than that. Great. What's next? Let's go ahead and list the contents of this root folder and see what's in there. So for this, I'm going to use a command called ls for list. So ls, enter, and it's going to show me a bunch of things. Now, don't worry about these different colors or symbols. Most of these are just like folders or directories. Let's take some of them, for example, to talk about. The etc folder here is where system-wide configuration files would typically live. The home folder here is where our own files and folders would typically live. The, let's say, opt folder here is where third-party software would typically be installed. The temp folder here is where temporary files would be would live usually. The user folder is where some programs and some libraries that are used by these programs and by the system would live. And there's quite a few more, but many of these are standard Linux folders that you're going to find on any Linux distribution that you're going to use. And there's conventions for as to what gets stored or what lives in these folders as well. So these were the contents of my root folder. Let's go ahead and go to the folder called home. How do I go ahead and do that? How do I go ahead and go inside of my of the home folder? cd space home is one way, using the relative path of the home folder. What's another way? So this is correct. cd/home, using the absolute path for the home folder. This is also correct. cd./home, using again the relative path of home folder of home, but being more explicit this way this time. Dot meaning start from the current folder and then go inside of home. All right, so I'm going to cd tilde is not quite correct, and we'll see why in a second. So this will take us inside of the folder called home. All right, let's see what's inside of this folder. So I'm going to use ls again for list to list the contents of the current directory. Enter, and it's showing me two folders here, CS50 and Ubuntu. So these are the contents of my home folder. I'm going to go ahead and go inside Ubuntu. So I'm going to do cd space Ubuntu, enter, and you'll notice something is different here. What is different, or what is not expected that we see in the terminal right now? Tilde appears. Yeah, this is interesting. So it turns out that in Linux, you can have more than one user. Each of these users would have a username and maybe a password. And each of these users can have what is called a home folder configured for them. So the home folder for a user is typically where this user would be able to store their files and folders and work on them. And it turns out that in the CS50 IDE itself, we are logged in as a user called Ubuntu, whose home folder is configured to be /home/Ubuntu. Tilde represents the home folder of the current user. So once again, just to recap, Linux can have more than one user. Some of these users can have home folders configured. We are logged in by default as user Ubuntu in the CS50 IDE, whose home folder is configured to be /home/Ubuntu. Tilde represents the home folder of the current user, whatever it is. So tilde in this case represents /home/Ubuntu. All right, so let's double check this. Let's verify this. There's another command that shows you the absolute path of the folder that we're in right now, called pwd for present working directory. So if I do pwd and press enter, it's going to show me the absolute path of the folder that I'm in right now, which is /home/Ubuntu, as you see. And this is represented by tilde. So tilde is just a shortcut for /home/Ubuntu in this case. Any questions on tilde or the home folder for our user? Is it possible to change users in the command line? Yes, but we're not going to talk about that today. If Ubuntu is a user, does this mean that CS50 is also a user? Yes. So CS50 happens to also be a user inside of the CS50 IDE. So this is the home of the Ubuntu user. Yes. So when I say our home folder, this means the home folder of the Ubuntu user, which is /home/Ubuntu. This is different from the folder /home itself, which is literally called /home. Good question. Why can't we use tilde to return to home? You can. So if you go back to the root folder, for example, I can do cd space tilde, and that will take me back to my home folder. So we can use tilde as a shortcut. This is one of the reasons why it exists, is that we often find ourselves wanting to go inside of our home folder frequently, and instead of just typing /home/Ubuntu every time, or trying to type the relative path for that folder, we can just type cd space tilde and it'll take us back to the home folder. Why is there a slash after the folder names? So the slash after the folder names are just separators. So they are completely optional, but they are just separators between the different folder names on the path. The very first slash, so if there's a path that starts with a slash like this represents the root folder, which is the topmost folder in our file tree. So this is what the different slashes mean. All right, great. Let's move on. Let's go ahead and clear our screen here. And what else can we do? Let's go ahead and list the contents of our home folder. So I'm going to do ls, enter, and nothing comes up. And this is expected because we haven't created any files or folders just yet. So let's go ahead and do that. Let's go ahead and create a file called foo, for example. So I'm going to use a command called touch to create an empty file. So touch space and then the name of the file or the path to the file, foo. So you want to create an empty file called foo, enter, and nothing seems to be happening. And usually when nothing seems to be happening, that means that we didn't get any errors, and that means that our command succeeded. So let's go ahead and list the contents once more. So ls, enter, and we can now see foo listed as a file or an entry in our home folder. Great. So this is how we can create a file or an empty file. How about creating a directory or a folder? So for creating a directory, we are going to use a different command called mkdir. So mkdir space and then the path to the directory that we'd like to create or the name of the directory that we'd like to create. And let's say we'd like to create a directory called seminar. So mkdir space seminar is going to create a directory called seminar in the current folder. Enter. Nothing seems to be happening like before, but if I do ls once more to list the contents, I'm going to find foo, the file that I created earlier, and then seminar, which is the folder that I just created using mkdir. All right, so any questions on touch or mkdir so far? How do I clear my terminal? I press Control L on my keyboard for clear, to clear my terminal, but you can also run literally the clear command and hit enter, and that will clear your terminal as well. So this is one way I can clear my terminal. What's the difference between a directory and a folder? They're the same thing in Linux. So in Linux, a directory is the same thing as a folder. How do we put foo in seminar? That's a great question and a great segue to my next command here. So suppose I'd like to move my foo file from my home folder inside of my seminar folder. How can I go ahead and do this? For this, I'm going to use a different command called mv for move. So mv space the source of the source or the file that I'd like to move. So foo space the destination, which is the folder that I'd like to move it into. So seminar in this case. Enter. Nothing seems to be happening here, but if I do ls once more, I see that the foo file disappeared. Presumably it's inside of my seminar folder right now. So let's go ahead and list the contents of the seminar folder. So ls space seminar, enter, and it shows me that foo is inside of seminar. So once again, if I do just ls, it lists the contents of the current folder. But if I do ls space a path to some folder, it will show me the contents of that folder. In this case, seminar, and the contents are just a file called foo. All right. So the next step I'm going to do is change my directory inside of my seminar folder. So to do that, I'm going to use my cd command again. So cd for change directory, space, seminar, enter. And you'll notice here that the shell prompt changed once more to confirm that I'm right now in my seminar folder inside of my home folder. Do ls once more. There's foo in there. All good. What else can we do? So suppose that I don't like this name foo, and I'd like to rename it to something else, like welcome, for example. So I'd like to rename my foo file to welcome. How can I go ahead and do this? So it turns out that mv, the command move, not only moves files and folders around, it also renames them. So I can say mv space the name that I'd like to change, foo, space the new name, say welcome, enter, and that will do nothing. But if I do ls once more, I'm going to find that my foo welcome's gone, my foo file is gone, and welcome appeared in the folder. So the name of the foo file changed to welcome. So this is how I can rename a file or a folder. Any question on the mv or move command? What kind of file is welcome? This is a great question. Welcome in this case is just an empty file. It doesn't have anything in it. How to move and change the name at the same time. Can we do this? Yes, let's actually demonstrate this. So suppose that we have another folder called test. So I'm going to create a new folder called test using mkdir space test, enter. If I do ls once more, I can see that I have my welcome file and my test folder. Suppose I'd like to move my welcome file inside of my test folder, but at the same time, rename the welcome file to something like bar. How can I do this? I can say mv welcome, the file that I'd like to move, and then space, and then the destination, test space test slash bar, the new name, enter. Oh, can't see. Okay, let me scroll back up. So I did mkdir to create a directory. Then I listed the contents of this directory. We have two entries, welcome and test. Then I moved my welcome file inside of test, but I called it bar this time. So right now, if I go ahead and go inside of my test folder using cd space test, enter, then list the contents once more, I'm going to see that my file called bar is inside of it. If I list the contents of the previous folder, the parent folder, seminar, I'm not going to find anything other than the test folder inside of it. So this is how I can move a file and rename it at the same time using a command like this. Good question. Now let me go back to the previous setup. So I'm going to go back to my seminar folder, and I'm going to go ahead and move the file test/bar back to welcome. All right, so if I do ls again, I see that I have welcome and test again in my seminar folder. If I list the contents of test, it has nothing in it. One way to get rid of an empty folder is using the rmdir command, so for remove directory. So rmdir allows you to remove an empty folder, and in this case, let's say we want to remove the folder called test. It's already empty, enter, nothing seems to be happening. But if I do ls once more, I only see welcome on my screen. So good question about move and renaming. Can we use a move? Can you use mv to move the file from one directory to another? Yes, that's what we just did. We use move to move a file or a folder from one folder to another, or to rename these files or folders. Would rmdir remove the contents of a folder? No. So rmdir would only remove an empty folder. There's a different way to remove a folder and all of its contents using a different command that we'll take a look at in just a moment. What is the extension of welcome? So it turns out that Linux doesn't care as much about extensions as, say, Windows. So Windows does care about extension a little bit more. In Linux, we don't really care that much about extensions. So in this case, yes, my welcome file doesn't have an extension. It's just called welcome. And it has nothing in it, so it's completely empty. All right, what else can we do? Let's say we wanted to list the contents of our root folder once more. So let's go ahead and do ls space / for list the contents of root. And this is what we saw before, a bunch of folders, maybe some files that are outputted to the terminal. And it turns out that if a command has some output like this, it by default writes this output to what is called as the standard output stream, or standard out for short, which defaults to the terminal. So this is why a command like ls writes output back to the terminal, as we see here. So any command that writes output by default usually writes it to the standard out, which happens to be the terminal by default. But it turns out we can change this. So let's say we would like to have ls write its output to a file instead of the terminal. So how can we do this? We can run a command like ls space / to list the contents of the root folder once more. But this time, I don't want it to be written to the terminal. I want it to be written to a file. So I'm going to use the greater than sign. And this is the output redirection operator. So we're redirecting the output from the terminal, which is the default standard out, to a file. So let's say root_list. This is the file that I'd like to write the output to. Enter. And you'll notice this time that nothing was outputted to the terminal. This is because the output from ls was written to root_list. So this is how we can redirect the standard output. Now, how do I view the contents of this root_list folder file? I can do this using a command called cat. So cat space name of the file, root_list, enter, and that will show me all the output of ls, as we can see here. So this is called output redirection, where we can have a command write its output to some other destination like a file, for example. And this can be done with any command that has output, not just ls. Is there any command to read files other than cat? Yes, there is at least one more way, and we're going to talk about that in a moment. What is the meaning of cat? Cat is short for concat or concatenate. And so one of the things that cat does is concatenate files together as well. What does the greater than sign mean? So the greater than sign, again, redirects the output of any command or program to some other destination other than the default one, which is the terminal. So by default, any command or program that writes output ends up writing to the default standard out, which is the terminal, but we can use the greater than sign to change that to write to a different destination, for example, a file. So I use this to write the output to a file called root_list in this example. Where is root_list located? It's located in the folder that I'm in right now, because I just said root list and I'm in my seminar folder. So root_list is going to be inside of my seminar folder. I would think of greater than sign as an arrow. Yes, it's kind of like an arrow. It says, hey, write this output to this thing here on the right. Yes, you can cat 2 or more files, and that would be shown. Yes. All right, all good questions so far. What else can we do with this? What else can we do with the command called cat? So if I just run cat without anything and press enter, you'll notice that nothing is happening, but I also don't get my shell prompt back, which means cat is still running. And it seems to be waiting on something. And in this case, it's actually waiting on input. So it's asking me for input. So I'm going to say hello, for example, and press enter. It's going to say hello back. Whatever I type in as input, it's going to write it back to my terminal. If I say hi, it writes hi back, and so on and so forth. So cat, if we run cat without anything, it's going to ask us for input, and it's going to write back whatever we type in back to the terminal, to the standard out. So to indicate that I'm done with this, I can press Control-D for done, and that will indicate to cat that, hey, I'm done entering my input, and I will get my shell prompt back so I can enter a new command here. So how can we use this with something like output redirection to have cat write to a file instead? We can run a command like cat space greater than sign or right arrow, hello, or let's say welcome, enter, and cat will again wait and ask me for input. So if I'm going to type hello in this case, enter, then Control-D to indicate that I'm done with my input. Nothing seems to be happening, but notice that this time cat did not print out back to the terminal whatever I typed, because presumably it got redirected to the file called welcome. So now if you view the contents of the file called welcome using cat as well, so cat space welcome to see the contents of the file, enter, and that will show me hello, the word that I entered before. So I was able to redirect the standard out for cat from the default, which is a terminal, as it wrote here, to a file called welcome. And now welcome has the word that we entered here, hello. Any question about output redirection so far? All right. Cool. All right, so so what is hello and welcome? It's just a string. Yes, it's just text in the file called welcome. All right, let's go ahead and do something else. Let's go ahead and try this again. So if I do cat greater than sign welcome, let's say something else this time. This welcome, let's say welcome to a taste of Linux. Enter, Control D to indicate that I'm done. Now if I do cat on welcome again to view the contents of the file called welcome, enter, you'll notice here that this is replace the contents of my welcome file from hello to my new line, which is welcome to a taste of Linux. So it turns out that when you redirect your output like this using a single greater than sign, it ends up overwriting the file with the new contents. But what if this is not what I want? What if I'd like to append something to the file instead of just overwriting the file? So for this, we can use a different operator, the double greater than sign. So double greater than sign, welcome, enter, and I'm going to say, thanks for joining, enter, Control D to indicate that I'm done. And now if I do cat on the file called welcome, once again, enter, I'm going to see the two lines. I'm going to see the line that I entered before and the line that I just appended here, which is thanks for joining. So single greater than sign redirects output and overwrites the contents of the file. Double greater than sign just appends to the file. So this is how we can use the append operator. What is the difference between Control D or Control C? So if you've taken CS50 or some other class before, you might have heard about Control C. Control C is used to interrupt a running program, usually to stop it. Control D indicates that, hey, we're done with our input. So if a program is asking you for input, you can say, hey, I'm done with my input. This is all I have. Is welcome a text file? Yes, it is a text file. It's a file that just contains text for now. Well, there are file types in Linux. So there are different file types in Linux. It's just that they're not differentiated by the extension as much as they are in something like Windows. What is the difference between greater than and double greater than? Again, greater than sign ends up redirecting the output and overwriting the contents of the file. Double greater than just appends to the file. All right, what else can we do? So once again, if I run cat just by itself, it's going to ask me for input, and anything that I give it, hello, hi, it's going to write back to my terminal. I can do Control D to indicate that I'm done. But what if this is not quite what I want? What if I want cat, instead of taking input from my terminal, from my keyboard, to take input from a file instead? Well, we can do this with the less than sign, as you might have guessed, which looks like a left arrow. So that means, hey, cat, do not take input from the standard input stream, or standard in for short, which defaults to the terminal, but instead take input from some other source, for example, a file. So we can take input from the file that we just created, for example, called welcome. So cat less than sign welcome, enter, and that is going to show me the contents of this file as well. So in this case, cat did not wait and ask me for input. It just read the contents of my welcome file and then printed it back to the standard out, which is the terminal by default. So this is called input redirection, and the whole thing is called input output redirection, or IO redirection for short, which is how we can redirect the sources from where we can take input and the destinations to where we can write output. Doesn't cat welcome and cat less than sign welcome do the same thing? Yes. In this case, they do the same thing, but in the first case, cat is just taking welcome as what is called an argument. So cat supports this to take the file name as an argument and then list the contents of this file, or it can read from the standard in, just like it did when it asked me for input right here. And I can redirect this standard in to be something else like a file, and it's going to show me the contents of this file. All right. Cool. So this is input redirection and output redirection. What else can we do with this? So what if I want to do both things at the same time? What if I want to redirect the standard in and the standard out at the same time? So read the input from some file and then write it maybe to some other file. Can I do this? And the answer is yes. So if I clear my screen here, I can have cat read the input from my welcome file, but at the same time, write the input back to the output back to a file called welcome1. So cat is not going to ask me for input at my terminal this time. It's going to read it from a file called welcome, and it's going to write the output to a file instead. And if I do this and press enter, nothing seems to be happening. Cat did not wait and ask me for input this time because it read the input from the file called welcome, and it did not show anything on the terminal, did not write any output to the terminal because I redirected the output to a file called welcome1. And if I do ls to list the contents once more, I can see that there's a file called welcome1 that appeared in my directory right now. If I do cat on welcome1, enter, that is going to show me the exact same contents that are in the file called welcome. So this is how we can redirect the standard in and standard out at the same time. Any question on input-output redirection so far? Can we create a file and write to it simultaneously using cat? Yes. So if I do ls once more, I'm going to see these entries here. I can simply do cat greater than sign test and then write, hi, how are you, for example, Control D, and that will create the file for me called test in this case, and write whatever I wrote to it, as we can see here. Can we add together two contents of the same file? Yes, so cat does support concatenating two or more files together. So if I do, for example, cat space welcome space test, enter, that is going to show me the concatenated contents of the file called welcome, which is welcome to this Linux and thanks for joining, and the file called test, which is hi and how are you. This is one way you can use cat as well, and you can obviously write this to something else like test1, for example, enter, and that will end up causing cat to concatenate these two files into a third file called test1. So if I do cat on test1 now, I'm going to find that it has the contents of these two files concatenated together. All right. Cool. So what we ended up doing right here is that by creating this welcome1 file is that we really ended up copying this file called welcome to a file called welcome1. But this is not necessarily the best way to copy a file. To copy a file or a folder, there's another command called cp for copy. So we can use cp, the file that we'd like to copy, welcome, to the file that we'd like to, the destination, which is welcome1, welcome2, for example. So this will have the effect of copying the file called welcome into a file called welcome2. If I press enter, nothing seems to be happening. If I do ls to list the contents once more, I'm going to see a new file here called welcome2. And if I cat this file welcome2, it's going to have the exact same contents from welcome as well. So we were able to copy welcome into welcome2 using the cp command. So this is one way we can copy files on the command line as well. Now, all right, so I certainly don't want like 3 copies of the same file here. It's probably enough to have just 1 copy of it for my purposes. So how can I go ahead and remove a file from my system? So to do that, we're going to use a different command called rm for remove. So rm space the name or the path to the file that I'd like to remove. So let's say we'd like to remove the file called welcome1. Enter, and it's going to ask me, remove regular file welcome1. I'm going to say yes or Y just for short and press enter. Nothing seems to be happening, but if I do ls again, we'll see that the welcome1 file is now gone. So this is how we can remove a file. We can also use rm to remove a folder. But this is how we can remove a file. Now, what if I want to do this forcibly? What if I'm pretty sure that I'd like to remove a file and I don't want to get this prompt to confirm that I'd like to remove the file? So for this, I'm going to use rm space -f or -f, the name of the file. So let's say I'd like to forcibly remove this file called welcome2. So -f is for forcibly remove. Enter. And nothing seems to be happening this time as well. But notice that I didn't get any prompt. I didn't get any confirmation that whether or not I'd like to actually remove this file. But if I do ls once more, I can see that the file welcome2 is now gone. So this is how we can forcibly remove a file. We need to be careful though when using something like this, because we can end up removing files that we didn't mean to remove. So -f here is for forcibly removing a file or a folder. Now, this -f part is kind of interesting. This is what is known as a command line option, or just an option for short. Pretty much all of the commands that we're going to be using today or demonstrating today are going to have some sort of options that they support. And these options, what they do is that they influence the behavior or change the behavior of the command based on what options we provide. But how did I figure out the existence of something like this -f option? Now, it turns out that most of these commands support a special option called --help or --help. So rm space --help, enter, is going to show me a short description of what the rm command does and how to use it. So this command removes the files, and it's used that way. You say rm, and then you mention one or more options, then one or more files, and that will end up removing them. And there's a bunch of supported options here, including -f or --force to ignore non-existent files and arguments and never prompt. So this is how I discovered the -f option for the rm command, and this is how you can discover some of the supported options for other commands as well. Now, if you'd like more details about this, if you'd like more details about the command itself and the options that it supports, and maybe some more details about that. So we're going to use a different command here called man. So man for manual page, and then the name of the command. It turns out many of these commands have what are called manual pages with more details about them. So man space rm will show me the manual page for the command called rm, enter. And that will show me a description for the command, maybe a little bit longer description down here at the bottom, some of the options that are supported, as we see here at the bottom, and maybe some examples as well. So this is what a manual page looks like. I'm going to press Q on my keyboard to quit my man page or manual page. So again, rm --help, and or man rm will give you some more information about the command and the options that it supports. Any question on rm, man, or any of the commands that we talked about before? what does man do again? So man is a command that shows me the manual page for some other command, right? So it turns out many of these Linux commands that we're going to be using today, and many other commands, have what are called manual pages with some detailed descriptions about what the commands do and what options they support and maybe how to use them. And so we can bring up this man page for one of the commands using the man command. So man space name of the command, like rm, for example, or mv, enter, and that will show me the man page for that command with all the information that I'd like to know. Is man CS50 specific? No, man is not CS50 specific. Man pages exist on pretty much all the different Linux distributions and macOS even as well. All right. So what if I'd like to do something, but I don't know what command to use? I don't quite know how to do it. So for this, we can use the man command to search for a keyword in the manual pages to figure out what command can we possibly use. So for example, I'm going to do man -s1 -k remove. So what this means is, hey man, or manual page for commands, search for the keyword called remove, as indicated by -k remove here, in the manual page section 1. And it turns out there's quite a few sections for manual pages. If I do man to view the man page for man itself and scroll down a little bit here, you're going to find that there's a bunch of sections, 9 sections or so, for these manual pages by category. And in section 1, there is manual pages for executable programs and shell commands. So if you'd like to know what command to use by searching using a keyword, we can search in the section 1 of man pages. I'm going to press Q to exit. So if I do man -s1 -k remove, hey man remove, hey man search for the keyword called remove in the section 1 of man pages, enter, and this is going to show me a bunch of results, as we see here. Among these results is the command called rm, which removes the files or directories, and the command that we used earlier as well, rmdir, removes empty directories, and a bunch of other commands that are not relevant for this case, for this example. So this is how we can search the manual page sections for a keyword like remove or something else. All right. Any more questions on what does 1 do? So again, 1 is a section number for this manual page. We have multiple section numbers, 9 or so sections for the manual pages that are separated or different by category. The section 1 of the man pages are the manual pages for commands and shell programs. Can we get rid of the -s1? Yes, we can do that. So we can do man -k remove, and that will search in all the sections of man pages. So this is going to show me quite a few more results that are not necessarily commands and they're not necessarily relevant for my use case. So if I do this, I'm going to see a lot more results here, as we can see. I'm still going to find, if I look hard enough, the rm and rmdir commands that I need to use. But you're going to find a lot more results as well. So all these numbers in parentheses indicate that, hey, this is from section 3, this is from section 3, and so on. It's from section 2, and so on. What does -k mean? -k means here comes the keyword that I'd like to search for. So -k, and then the keyword that I'd like to search for is going to search the manual pages for this particular keyword. All right, let's go ahead and take our first activity for this seminar. Let me go ahead and switch to my slides on activity 0. And in this activity, we are going to do 4 things. We are going to create a directory called activity 0 in our home directory, or tilde. We are going to change our current directory to the activity 0 directory. We are going to write hello world to a file called hello. So maybe using something like cat. And then we are going to print the contents of our hello file to the standard out, which is a terminal by default, maybe using something like cat as well. So let's go ahead and work on this. If you'd like to get any hints or look at any of the commands that we've used so far, you can find a list of them at cs50.ly/seminars/linux/commands. And if you have any questions, definitely feel free to ask in the chat or on the ed discussion forum at cs50.ly/seminars/ed. Let's take 5 minutes to work on this, and then we'll come back. All right. Welcome back, everyone. If you couldn't quite figure this out, it's quite okay. These things can be very tricky at first. We're going to go ahead and walk through a solution, so feel free to follow along with us. So let me go ahead and switch back to my IDE here. And let me clear my terminal just so we can start clean. All right. So the first thing that I need to do is create a folder in my home folder called activity0. So one way you can do this is by first changing directory to our home folder and then creating a folder. So how can I change directory to my home folder? I'm seeing cd space ... which is correct because the home folder is the parent folder of my seminar folder that I'm in right now. So cd ... would work. cd tilde, which is the shortcut for our home folder, also works. So this is also correct. This will take me back to my home folder. It turns out that just cd will also work. So cd, enter, if I enter cd without any path and then enter, this by default is going to take me back to my home folder. So this is also a handy shortcut. cd/home/ubuntu using the absolute path of the home folder. Yes, I can do that as well. That would also work. Okay, so I'm in my home folder right now as indicated by my shell prompt. How can I go ahead and create a folder called activity0? What command do I use? How do I clear the terminal? You can clear the terminal by pressing Control L or clear, or type clear, and then press enter. That will clear the terminal as well. All right, so to create a folder called activity0, as everybody's saying, I'm going to use the mkdir command space the name or the path to the folder that I'd like to create, which is activity0, enter. And if nothing seems to be happening, which is good, if I do ls once more, I can see that I have a folder called activity0 in my home folder right now. Okay, the next step is to change directory to my activity0 directory. How can I do this? So for this, I'm going to use cd for change directory once more, then activity0. And notice if you type out, part of the name, like, AC, a couple of letters, for example, and press the tab key on your keyboard, this is going to end up auto-completing for you. So this can save you some time as well. So cd space, and then type a couple of letters from the name, and then hit the tab key on your keyboard, enter, and that will auto-complete for you. So I'm now inside of my activity0 folder, right? If I list the contents of this folder, it's completely empty. Now, the next step is to write hello world to a file called hello. How can I do this? I can certainly touch hello first and then write to it using something like cat. But even if I do just cat greater than sign hello, as some people are indicating in the chat, this is going to create a file called hello for me, even if it doesn't exist. So touch hello and then cat to hello would also work. But we're just saving a step by writing to hello directly and having that be created for us automatically. So enter, I'm going to type in hello, world, enter, and then what do I do to indicate that I'm done with my input? Control D for done, to say, hey cat, I'm done with my input. And if I do this, I get my shell prompt back. Now, if I do ls once more, I can see that a file was created in my folder right now called hello. And how do I view the contents of this file? Cat space hello. That will show me the contents of the file. And that says hello world exactly as I wanted to. All right, great job. Cool. What's next? So the next command that I'm going to show you, first of all, let me pause to see if we have any questions on this activity or any of the commands that we've used. All right, let's move on. So let me clear my screen. And the next command that I'm going to show you is called WC for word count. So word count takes input from the default center in, which is the terminal, and shows me some useful information about this input. So let's say I run WC on its own, and it's waiting for input just like cat did when we tried it, I'm going to say, foo bar as quarks, a bunch of just random words, and then Control D to indicate that I'm done with my input. And it's going to show me 3 numbers down here at the bottom. The first number represents the number of lines that I entered as my input. So 3 here is 3 lines. 4 represents the number of words that I entered, which is 4 here. So we have 4 words, 1, 2, 3, 4. And then 16 represents the number of bytes of my input, or the size of my input in bytes, which is 16 bytes in this case. I knew this just by looking at the documentation for the WC tool or word count or the man page. So if you do man space WC, that'll show you information about WC, what options it takes, and what these numbers mean. All right, what else can we do with WC that's maybe a bit more interesting than this? So it turns out that one of the options that WC takes is -L or -L. So if I do WC-L, it's going to ask me for input like before. I do foo bar, baz, quarks. There's a bunch of random words here. Control D to indicate that I'm done with my input. And in this case, it's going to show me the number of lines only. So -L causes WC to only show me the number of lines, which is 3 in this case. All right. So this is some of what WC can do for us. Now, the reason I introduced this is that I wanted to introduce a different form of input-output redirection, or I/O redirection, called piping. So let me go ahead and go back to my seminar folder in my home folder. How do I go ahead and do this? How do I go to my seminar folder inside of my home folder? So CD seminar is not quite going to work. Why? So if I do this, CD space seminar, it's going to show me no such file or directory. The reason why is that there is no seminar folder in my current folder, which is activity 0. My seminar folder lives in my home folder. So I can do, yes, as people are saying in the chat, I can do CD space /seminar, which means go to the parent folder, then the seminar folder inside of that folder, enter, and that will take me to the seminar folder inside of my home folder, as you see here in the shell prompt. All right, CD tilde seminar works too, using the absolute path for the seminar folder. So that is correct as well. All right, so I'm in my seminar folder. If I do ls again, I see my welcome file and a bunch of files that I created before. Now, what is piping? So let's do something like this. Let's do cat welcome. So again, cat welcome just shows me the contents of the file. If I do cat welcome, then vertical bar wc-l. What would that do? So this is what is known as piping, or a pipeline, where you can chain 2 or more commands and have the output of one command, in this case cat welcome, be fed as input to another command, in this case wc-l. So what this command is going to do is going to take the output of the cat welcome command, which is normally these 2 lines, and feed it as input to the command after the vertical bar, which is wc-l. So let's see what this does. Enter, and that is going to show me 2, which is 2 lines, the number of lines that are in my file. So this is piping, and you can pipe more than 2 commands. You can just, you don't have to pipe just only 2 commands. You can pipe more than 2. So if you have a command called A, for example, a command called B, and a command called C, and so on, you can say A vertical bar B vertical bar C, or A pipe into B pipe into C, and that will take the output of A, feed it as input to B, and then take the output of B, feed it as input into C, and then show the output to the terminal. All right, so this is piping. Great question. What is the difference between greater than sign and the vertical bar? So in case of the greater than sign, when we redirected the output, we ended up creating a file and writing the output to that file. In case of using piping, we don't need to create a file. So we can just directly take the output of some command and then feed it as input to another command without necessarily writing anything to a file. Let me demonstrate this. So once again, if I run cat just on its own, if I type hello, it says hello back. If I type hi, it says hi back, and so on. So it takes input from the default standard in, which is a terminal, and it writes output back to the default standard output or standard out, which is also the terminal. But if I do this, let's say we do cat, let's clear the screen, cat vertical bar wc-l, enter. If I type in, so cat is asking me for input again. If I do hello, nothing is happening. Hi, nothing is happening. Control D, it's going to print 2. So what it did is that instead of cat printing out or writing back my input to the terminal, it got fed as input to WC. And then WC took that as input and showed me the number of lines that I have, which is 2. So this is the difference between greater than sign and a vertical bar or piping. All right. So piping is, again, another form of input-output redirection that we can use to chain 2 or more commands and have, one command write output that gets used as input by another command, and then we can have more of that. Any questions on piping so far? Can we write something else in place of -L? Yes, so WC has a bunch of other options as well. So if I do man WC or WC-L, maybe, that will show me a bunch of options that WC supports, including -L to count the number of lines, -M to count the number of chars, -C to count the number of bytes, and so on. So yes, we can use any other option other than the -L. All right. Can you use piping and use a variable to hold a value? Yes, but we're not going to talk about variables in this seminar, but it's possible. Can you use multiple commands which work independently? Yes, so long as you want to feed the output of one command as input to another command, you can use piping and do that. But yeah, they can be different commands, they can be independent commands. All right, so what else can we do? Let's go back to our home folder. So CD, just to go back to my home folder. And let's do something else this time. I'm going to go ahead and download a file to my CS50 IDE. So to download a file to my CS50 IDE, I'm going to use a command called wget. And then I'm going to mention the URL of the file that I'd like to download. So https://cdn.cs50.net/2021/x/seminars Linux shows.csv. So this is the URL of the file that I'd like to download to my CS50 IDE. And I just happen to know this off the top of my head, but it also exists in the slides if you'd like to copy and paste it instead of having to type it out. And I'm going to press enter to run my command. And I can see that a bunch of input flew by my screen here, indicating that my shows CSV file was downloaded successfully to my CS50 IDE. If I do ls to list the contents of the current folder, my home folder, enter, I'm going to see a file called shows.csv. All right, let's go ahead and see what's inside of this file. So I'm going to do cat space shows.csv to see the contents of my file, enter, and a bunch of lines are going to fly by my terminal. So this file has a number of TV shows from IMDb with their IDs, with their years, with their episodes, and a couple more things. And this is known as a CSV file, or comma-separated values, where each line is just a number of fields separated by commas, as we see here. So the first field here represents the ID, then comma to separate, then the second field is a show title, and comma, and the year, and so on. All right, so this is what my file has. And this is how I was able to view its contents using cat. But this is not probably the best way to view the contents of a file or interact with the contents of a file that big. How can we do better than this? How can we interact with a file in a better way? So for this, we are going to use a command called less. So less, and then shows.csv, the name of the file or the path to the file, enter. And that's going to open the same file and a file viewer of sort. Starting all the way at the top, so I see here the topmost line in the file, which represents the headers of my CSV. I can see the first column is the ID column, the second column is the title, and so on. And then each of these rows represents a show or information about a TV show. So this is less. Now, I can do a bunch of cool things with less using keyboard shortcuts. So this is one of the things that wasn't very accessible when we use something like cat to view the contents of the file. But I can do something like scroll down line by line. So if I need to scroll down line by line, I can just press the J key on my keyboard. So J to scroll down one line, J again, scroll down one line, J again, and so on. Right? So this is how we can scroll down using the J key. You can do the same thing by pressing the Enter key or Return key on your keyboard. So Enter will also take you down one line. If I wanted to go back up one line, I can press K. So K will take me back up one line, K again, up one line, and so on. So J down one line, K up one line. All right. What if I just take a look at this page and find nothing interesting? I just want to jump to the next page right away. How can I do this? What keyboard shortcut do I use with less? I can do this using the space bar. So if I press the space bar, it's going to scroll down, but not by one line this time, by one page. So space, next page, space, next page, and so on. If I wanted to go back to the previous page, I can press the B button for back. So back, B, back previous page, B, back to the previous page, B, previous page, and so on. So these are a few shortcuts that we can use with less. And by no means don't try to memorize all these shortcuts. I'm sure there's like a list of them somewhere that we can look up, and maybe over lots of use and lots of practice, we are going to sort of get used to this and start knowing them off the top of our heads, and be faster when working with something like less. So once again, spacebar, next page, B for back, previous page. What if I scroll down a few pages, like this, and I want a quick way to go all the way to the top of the file? So for this, I can press G. So press G to go all the way to the top of the file. What if I want to do the opposite? What if I'm, all the way at the top or somewhere at the top, and I'd like to jump all the way down to the bottom of the file? So I can press Shift G on my keyboard to jump all the way to the bottom of the file. So G goes all the way to the top, Shift G goes all the way to the bottom. And you can see here that less is saying, hey, this is the end of the file. I cannot go down any more than this. All right, so this is G and Shift G. What else can we do with less? So let me jump back to the top of the file by pressing G. Let's go ahead and search for something. So it turns out you can search for something in the file using less as well. And I can do this by pressing the / key on my keyboard. So as you can see here, the column at the bottom changed to /. So if I press that, and then the thing that I'd like to search for, and let's say we'd like to search for something for a show title that has the word the in it. So if I do / and then the, then press enter, that is going to jump to the first match if it found one. So the first show that has the word the in its title in this file is called, Third Rock from the Sun. All right. So what if I want to jump to the next match? So if there's more matches in this file for my search term, I'd like to be able to jump to the next match. And for this, we can press N for next. So N, jump to the next match, Beauty and the Beast. N, jump to the next match, and so on. All right. What if I want to jump back to the previous match? I can do this using Shift N. So Shift N to go back to the previous match of my search. So this is N and Shift N. If I do N a bunch of time for next, I'm going to notice something, that all of these exactly match the case of the word that I typed. So all of these are lowercase t, lowercase h, lowercase e. And notice that it's it's even sometimes part of a word, so not independently the word the word the on its own. It can be part of a word like father, and there are ways around this. But what if I want to search in a case insensitive manner. So I need to get some results that, maybe include some uppercase T or something. How can I do this? So if I press on my keyboard -I, so -I, that will toggle the case sensitivity search. So right here at the bottom, you'll see once you do -I, less is going to say ignore case in searches. Right? So now less is ignoring the case in my searches. So now if I go back to the top of the file and press / to search for the same thing. If I press N for next a few times, I can see now that some results start to come up, like the last airbender, for example, with a capital T. So this is how we can ignore the case of the letters that we are searching for. And we can toggle that using -I as well. So if I want to turn that off again, I can just do -I again. And you'll notice that less says cases significant in searches now. All right. So this is a few handy shortcuts that we can use with less. And if you notice from earlier, when we did man RM and man MV, the man by default opened the man page in less. So if you do man for some command to see the manual page for this command, you can use less by default to view the manual page. So these shortcuts can come in handy if you're trying to navigate this file or search for something. How to return to case sensitive? We just press -I. So -I again ignores the searches, it just toggles it. So -I ignores the searches. If I do -I again, it becomes significant once more. So these shortcuts work in man pages, yes. So if man pages open the man page in less, these shortcuts are going to be the same. And there's more shortcuts than this and more things that we can do with less. So this is just a taste of it. But yes, this should work with man pages as well. All right, so suppose I'm done with this file and I'd like to quit. I can just press Q on my keyboard and that will bring me back to my terminal. So Q for quit will bring me back to my terminal. Any questions on less so far? Can piping with other commands allow us to use less? Yes. So let's say I have my let's do the same thing. Let's say I have a file called welcome from before in my seminar folder. So if I cat seminar welcome, that is going to show me the contents of this file. But I can do the same thing. I can do cat space seminar welcome and then pipe that into less, because it turns out less also takes input from standard in if you run it without any files. Enter, and that is going to open my file in less. Now this file is pretty short, so I've just seen 2 lines and then the end. But I can, if the file was longer, I could maybe use some more shortcuts with it, and I can do the exact same things. So yes, you can pipe something into less and have less showed to you in this user-friendly way. So I'm going to press Q once more to quit my less program. What else? What other questions do we have on less? Can less edit the files? I believe yes, it can edit files. We're not going to go through it right now. And there are other command line text editors as well. 2 of the popular ones are Vim and Emacs and Nano. All of these are very popular command line editors that you can use to edit files right away in your terminal. All right. What is the difference between Vim and less? Vim is a text editor that can be used on the command line as well. It is going to be more sophisticated than less, with a bunch of more shortcuts and maybe some plugins and extensions that you can do cool things with it. Is Q the same as Control D? Not quite. So Q in this case is a shortcut defined by less for quitting less itself. Control D, on the other hand, if a command or a program is asking us for input on the standard in, we can press Control D to indicate that we're done with our input. What does cat seminar welcome less do? So cat seminar welcome pipe into less takes the output of this command, which is cat, which is the contents of the welcome file, these two lines, and feeds it as input to less. And the result of that is going to end up opening this output inside of less. So I can interact with it inside of less, just like I did with shows.csv. Great questions. All right, so we can do something like wc-l on the file called shows.csv. So if I do this, this is going to show me the number of lines in this file, which happens to be 500. So it's a fairly big file. What if I just care about the first few lines of the file instead of all 500? So for this, we can use a command called head. So head and then the path to the file, shows.csv, enter. And this is going to show us the first 10 lines or so from the file. So once again, head shows us literally just that, the head of the file, which is the first 10 lines or so. But we can change that. So it turns out if you look at the man page for head, or you look at the --help or -h option, you can see head. You'll find that head minus n, 28, for example, is going to show me 28 instead of 10 lines of the head of the file. So from the beginning of the file, we have 28 lines now instead of just 10. All right, so head minus n, 28 shows.csv, shows me the first 28 lines from this file. What if I want to do the opposite? What if I want to see, the last 10 lines or so from the file? For this, I can use a command called tail. So tail shows.csv is going to show me the last 10 lines from this file. And we can do the same thing and pass minus n, 28, to show more lines or some specific number of lines. So this is going to show me the last 28 lines from the file or so instead of the last 10. All right. So this is how we can use head and tail. And notice that we can also pipe stuff into head and tail. So it turns out if I run head or tail, they also support taking input from standard in. So I can do something like cat shows.csv, pipe into head, and that is going to feed the output of cat.csv into head as input, and then head is going to end up showing me the first 10 lines from the file as well. All right. Who makes these command names? A lot of people do. All right. So this is what we can do with head and tail. And once again, we can pipe any command, not just cat. Like if we have any command that outputs something to standard out, we can just pipe this output into head or tail if we just care about the first few lines or the last few lines of this output. What else can we do? Let's do something maybe a bit more fancy than this. So once again, if I open this file, shows.csv, in my terminal, this is a CSV file, which is short for comma separated values. Each one of these rows represents a show, a TV show, where the first column is represents the ID, the second column represents the title of the show, third column is the number of years, is the year that it aired in, and so on. And all of these columns or fields are separated by commas, as we see here. Hence the name comma separated values, right? What if I just care about the first column from this file instead of the whole thing? So for this, we can use a command called cut. So cut, I'm going to do cut minus d, comma, because these fields or columns are separated by commas, minus f, I care about the field number 1, which is the first field, the ID field, from shows.csv. So once again, cut minus d, comma, because my fields or columns are separated by commas, minus f1, because I only care about the first column or the first field from the file, and then the name of the file that I'd like to get this or select these fields from, enter, and that is going to show me the first column from the file, which has the IDs. All right, So this is how we can use cut to select certain fields from the file. Can we select more than one field, for example? Yes. So let's do this again. And I press up on my keyboard, the up arrow key, to scroll to a previous command that I entered in the terminal. So you can scroll up and down to scroll through your command history. And if I do, let's say, I care about the field number 2 and the field number 3, which happens to be the title and the year of the show. Enter, and that is going to show me just that. So you see, the show title here, and then followed by the year. Show title followed by year, and so on. What is the use of the comma here? So the comma after the -d says to cut, hey cut, these fields, the fields in this file, are all separated by commas. So this is just for cut to know how it can divide this file into fields or columns, but it can be anything else. So if your fields are separated by some other symbol, a space, for example, or character, you can specify as much. What does -d stand for? -d stands for delimiter or separator. Yes. All right, so this is what we can do with cut. And notice that we can still, like, this command has some output. We can still feed this output into, or pipe this output into some other program like head, for example. And that is going to show me, the first 10 lines from the output, for example. All right, so this is how we can pipe any command into any other command, pretty much. Any questions on cut so far? Is the old file still there? Yes. So what cut does is just, reads the input from the file, but then writes by default everything to standard out, which happens to be the terminal. If I open the file again in less, for example, or if I view its contents with cat or with head and tail, we are going to see that the contents of the file are still the same. What if they are tab separated? So you can specify this. It's a bit tricky to specify tab here on the terminal, but one way you can do it is, I believe, by, whoops, not this, believe by pressing maybe Control-Shift-V and then tab. Yeah. So in the terminal, you're going to do -d, Control-Shift-V, tab, and then close quote, and that will specify that the delimiter should be the tab character between these quotes. Anytime you have a space or a special character in one of these arguments, it's always a good idea to surround this argument with like single quotes or double quotes to avoid any confusion for bash itself, your shell. All right. Yeah, so if they are separated by tab, I can do, I can open a quote, because this is a white space, one of the white spaces, Control-Shift-V, and then hit the tab key on my keyboard, and then close quote, and that is going to cut by tab. All right, good question. So is it a delimiter in the demo? Yeah, so the delimiter that we have in this file is just a comma, but it could be anything else. And you can specify this with a -d command line option. All right. So what else can we do this? Let's open this file in less once more. And one of the things that I don't like about this file is that these IDs in the first column seem to be randomly sorted. And I'd like to sort this file by ID. How can I go ahead and do this? So for this, I'm going to use a command called sort. So sort, and then the name of the file or the path to the file, shows.csv, enter, and sort is going to write to the standard out, which is the terminal by default, the sorted output. But something is weird about this sorted output. Notice that some big numbers come before some smaller numbers, which is not quite right. And this is because by default, sort sorts these values by doing something like all ones come first, then all twos, then all threes, then all fours, and so on and so forth. which is not quite what I want. It's sorted in a way, but it's not quite what I want. What I want is I want to respect these numeric values that are for the ID column and sort by these, right? So to do that, if I look at the man page for sort, I'm going to find that -n does exactly that, sort using the numeric values. So sort -n and then shows.csv. If I press enter now it's sorted the way that I want. Smaller numbers first and then the bigger numbers at the bottom or toward the bottom. All right, so this is how we can use sort to sort the lines in a file. All right, and notice if I open the file again in less, for example, shows.csv, once again it's still not sorted because sort does not change the contents of this file. It just writes the output to the standard out, which is the terminal by default. But what if I want to change this? What if I want sort to write the output to some file, to save this output to a file? How can I do this? What symbol can I use to write the output or save the output to a file? Greater than sign, yes. So if I do sort, like before, press up on my keyboard to scroll through the command history, sort-n shows.csv. But instead of writing to the terminal, I want you to write to a file called shows_sorted.csv, for example. So the greater than sign is going to redirect the output from the terminal, which is the default, to a file called shows_sorted.csv. If I press enter now, I see that nothing was written to the terminal, right? So if I open the file, if I do ls, I can see that a file appeared in my folder called shows_sorted. And if I open this file in less, for example, shows_sorted, enter, that is going to show me the sorted output, which is the result of the sort command. So I was able to save this result in a file using output redirection or the greater than symbol. Can you redirect to a file without extension? Yes. So once again, Linux doesn't care that much about extensions. So I can say redirect to a file called shows_sorted. If I do ls, I can see a file now called shows_sorted. If I do that, less shows_sorted, it's going to open the same file and show me the sorted output. All right, so Q to exit or quit from less as well. So this is how we can sort some files. Can we sort by some other key? Can we sort by some other column? Yes. I'm going to leave that for you to explore. If you open the man page for sort, you're going to find maybe one or more options to select what field or what separator to sort with, instead of just the first, instead of from the beginning of the line to the end of the line. All right. Yes, so piping will also work. So suppose I care about, the first 10 lines of the sorted output. I can pipe this into head, and that will show me the first 10 lines. If I care about the first 20 lines, I can pipe into head -n20, and that will show me the first 20 lines from the sorted output. And I can do the same thing with tail or any command that takes input on standard in. What does -n stand for? So -n is one of the options for sort. And that means, hey, sort, respect the numeric values of these strings. So to sort in a with respect to the numeric values of these strings instead of just the representation. For head, -n just means I care about this specific number of lines. So in this case, 20 lines from the top of the file or the top of the output. All right, so this is sort. Now, what if I want to search for something in the file, but I don't quite want to open this file in some program like less? So can I use a command to search for something in a file without opening it? And the answer is yes. We can use a command called grep. So grep will let me search for something in the file, without necessarily opening this file. So grep, let's say I'm going to search for friends in this file called shows.csv, enter, and you're going to notice that it shows me the matched lines that has friends in it on standard out. Now, notice if I do grep, friends, all lowercase, shows.csv, that it's not going to show me anything this time. And this is because, again, by default with grep, the case of whatever I'm searching for matters. So if I'd like to ignore the case, I can do grep-i for ignore the case. Then I can do lowercase friends in shows.csv, and this is going to show me the same result from before. So grep -i ignores the case in the search. So regardless of whether this is uppercase or lowercase, you're going to find any matches that match this. So this is how I can use grep to search for something in a file. Can I search for something that is more than one word? Yes, I can do that. So let's say we'd like to search for Game of Thrones, for example. And notice that this has to be inside of quotes this time because we have spaces in our search term. And anytime you have spaces or special symbols in one of these arguments, you probably want to surround it with quotes just to be safe and not confuse your shell. So if I do this, press enter, it is going to show me the line that matches Game of Thrones from this files. Does grep only return the first result? No, grep does not only return the first results. Grep can return more results if it found more than one. So let's say any show that has the word game in it or has game part of its title. Enter, and it's going to show me Sacred Games and Game of Thrones, as we see here. But we can limit that. So there's an option to grep that I can say, hey, grep, show me the first n matches only if you found them. And we can know that by looking at the man page for grep as well. Can we use wildcards in search? Yes, so you can use a pattern. You can use what is known as a regular expression. If you're familiar, we're not going to talk about regular expressions in this seminar, but regular expressions are simply a way of specifying a pattern to search for instead of an exact search, right? So I can do something like grep, anything that starts with 28. So this caret symbol in regular expressions means anything that starts with the following, let's say 28, from shows.csv, enter, and that is going to show me all the lines in the file that start with 28. So we can use patterns or regular expressions to search for something instead of exactly typing out that thing, if we want that. All right. One of the options, how to search for certain words, one of the options, if I open man grep, one of the options that you'll find here is -w, I believe. So if I search for -w, yeah, so -w is only going to search by words. So it will consider what you're typing in to search for as a single word. All right. So what else can we do? Any questions on grep so far? Any more questions on grep? Can we use and or arguments in search? Yes, you can do that. But this is regular expression specific format syntax that I'm not going to go through in this seminar. But you can definitely learn about the regular expression rules or syntax online, and you can use regular expressions to search for something or something else, for example. All right, cool. What else can we do with that? So let me grep for something else. Let me grep for a show called Seinfeld. All right, one of the most popular shows as well. Enter, and I found a match. All right, but there seems to be a typo in the name of the show. The show is supposed to be called Seinfeld, not Seinfeld. So can I fix this typo without necessarily opening the file in a text editor using a command? And the answer is yes. So one way to do this is using a different command called sed. And sed, the syntax for sed can be a bit complicated at first, or or even if you use it for sometimes, it can still be a bit complicated. But here's an example. So sed s Seinfeld to Seinfeld / shows.csv. And what this is going to do is say, hey, sed, read the contents of shows.csv, but replace the occurrence of Seinfeld with the correctly spelled one, which is Seinfeld. And then let's do something else. Let's pipe this into grep. So grep, like before, for Seinfeld. So instead of writing the whole thing back to the terminal, just grep Seinfeld from the output. And if I do this, enter, I will see that the typo was fixed in this output right here. But if I open the file again, or if I grep for Seinfeld in file again, so if I grep for Seinfeld in shows.csv, enter, it's still mistyped. It still has a typo in it, right? And this is because, again, most of these commands write to standard out by default. They don't change the contents of these files. How do I do this? How do I save the fixed output to a file? So greater than sign, yes. So I can redirect the output. So by default, if I do this without any redirection, it's going to write the whole output to the terminal. But if I want to save this output to a file, I can do sed and then my command and then greater than sign to redirect the output. Let's say shows_fixed.csv. Enter. No output to the terminal this time, but if I grep for Seinfeld inside of shows.csv or showsfixed.csv, I'm going to find that it's correctly spelled. So this is how we can use sed to fix or change, replace anything in a text file. Sed can do more stuff than this, but we're not going to dive into this for now. We're just going to demonstrate this. It turns out one of the options for sed as well, if you would like to fix something in the file itself, if you're absolutely sure, you can use sed -i, and then the same command, Seinfeld, replace Seinfeld with Seinfeld in the file called shows.csv. This -i means replace in place. So in the same file, right? So if I do this, press enter, nothing will be written to the standard out. But if I grep for Seinfeld in shows.csv once more, I'm going to find that the typo was fixed in my file. All right. So this is how we can use sed to replace parts of a file. All right. I noticed that I keep typing grep-i over and over again. And it turns out that there's a way to create alias commands for any command that I want. So to do this, there's a command called alias. So alias, let's say I want to create an alias for grep-i. Let's say I'm going to call it igrep this time. So alias igrep to grep-i. What this is going to do is in this terminal session, it's going to, whenever I type in igrep, it's going to act as if I typed grep-i instead. So alias igrep equals quotes grep-i, enter. Nothing seems to be happening. But right now, if I try to use igrep Seinfeld on shows.csv, enter, that is going to do grep-i for me on Seinfeld shows.csv, and it's going to show me the matching results if it found any. So alias is a command that we can use to create aliases for other commands that we have, just in case we want to save some time by creating these aliases. All right, so you can create aliases for even more complicated commands than this. Now, there are ways to have aliases persist across shell sessions or terminal sessions. We're not going to go through that now, but for now, if you run this in a shell, it's going to last only for the period of the shell. So if you open a new shell or open a new terminal, you're not going to find this alias by default. But again, there are ways to persist this. All right. Now, what other commands can I show you? Okay, so there's a command called history. So history is a command that shows you just that, the command history for every command that you just typed, right? So if I just run history and press enter, it's going to show me the history of my commands. Once again, I can scroll up through these commands or through this command history by pressing the up arrow in my keyboard down to scroll down. All right, and I can do history, and pipe that into something like head to see the first 10 commands, for example, that I entered today. I can do pipe into tail to see the last 10 commands, for example, or I can grep on this, so I can do history, pipe into grep, or pipe into igrep. Let's say I don't know, CA, any command that has CA in it, and that will grep for the commands that I have that have CA in them. So you can also do this. So this is history. Okay, what else can we do? One of the things that we need to do quite often is search for a file or a folder in our system. And one way to do this is using the find command. So if I do something like find /user -name CS50.py, this is going to try to find any files or folders that are called CS50.py anywhere inside of my /user folder. Right? So once again, find /user. Hey, find me anything inside of the /user folder whose name is CS50.py. And if I do this and press enter, it's going to take a second, and then it's ultimately going to find something like this. So this is the path of the file called CS50.py in my /user folder. Now I can use patterns or wildcards with this as well. So I can do something like, suppose I want to find anything that starts with the name CS50. Instead of there's just specifically CS50.py. How can I do this? I can do find /user name CS50 star. So this star is a wildcard that can be used with find. That means I want to find anything that has CS50, that starts with CS50 followed by anything. Right? So find this in my /user folder and show me the results. So if I press enter this time, it's going to show me a bunch of results, including something that's called CS50.h, a folder called CS50, a file called CS50.py, a file called CS50.jar, and so on. So this is how we can find a file or a folder anywhere in our system. So we can say find, and then the folder that we'd like to look into. So this can be /user or it can be anything. It can be slash, can be /home, can be /etc, any of these folders, to search specifically within these folders. Any question on find? Can you pipe the output of find into some other command? Yes, any command that has output can be, you can pipe this output into some other command that takes input. So let's say I care about the first 3 matches of these. So I can do head-n3, enter, and that will end up showing me just the first 3 matches or the first 3 lines from this output over here. What is the difference between the caret symbol and the star symbol? So the caret symbol is a regular expression symbol. It means anything that starts with the following in regular expressions. Find, I don't think it supports, well, it might support regular expressions, but it might need to take some options. If I do man find, yes, so you can use regular expressions with find as well, but by default, it doesn't use regular expressions. So star in this case, it's just a wildcard for anything. So if I do find, like before, find user CS50 star, that means anything that starts with CS50 followed by anything. Yeah, can you search more broadly? Yes, so we can search inside of the root folder, which is the topmost folder in our file tree, as we said. This is probably going to take more time because it's going to maybe search inside of more folders if we didn't know where CS50, where the file that we're looking at we're looking for is, but we can search within any folder in our system. Or home, yes, we can search within home. So tilde, that is also going to work. All right, so this is fine. Let's go ahead and take our second and final activity for this seminar. So let me switch back to my slides to activity 1. And in this activity, we are going to do 5 things. We are going to create a folder called activity 1 in our home folder, like before. We are going to change our folder to the activity 1 folder that we just created. We are going to download the file called shows.csv, maybe using something like wget, like we did. And you can copy this URL from the slides if you don't want to type it out. And then using a pipe, we are going to print what year did Mr. Robot air in to send it out to the terminal. This is number 4. Print the year that Mr. Robot aired in from the file called shows.csv. And then number 5, finally, is to find the location of the file called libcs50.a inside of /user. So how can we find the location of libcs50.a inside of /user? Once again, if you'd like to get any hints or look something up from any of the commands that we have used so far, you can go ahead and visit cs50.ly/seminars/linux/commands to see a list of these commands. And if you have any questions, definitely feel free to ask in the chat or on the Ed discussion forum at cs50.ly/ed. Let's take 10 minutes to work on this activity, and then we'll come back to wrap up. All right. Welcome back, everyone. Once again, it's totally fine if you couldn't figure this out or couldn't get your commands to work. Totally okay. We're going to walk through a solution here. So definitely feel free to follow along with us. So let's go ahead and just do that. All right, so I'm going to go back to my CS50 IDE. And the first step is to create a folder called activity1 in my home folder. So if I'm not in my home folders already, I can go ahead and go to my home folder and do that. But I am already in my home folder right now. So what command do I use to create a directory called activity1 in my home folder? Make dir for make directory. So make dir space, and then the name of the directory that I'd like to make, which is activity1. Yep, like everyone is saying, that is exactly right. So make dir space activity1 to create a folder called activity1 in my home folder. If I do ls to list the contents of my folder, I can see that my activity1 folder is now created. Now, how do I go ahead and change directory to my activity1 directory? cd space activity1. Yes, that is exactly right. So I can do cd space activity1 to change directory inside of my activity1 directory. And you'll notice here that the shell prompt is different. It says that I am in my activity1 directory inside of my home directory, which is exactly what I want. Great. So what is the next step? The next step is to download this file called shows.csv. So how can we download this file? What command do we use? Yep, everyone's saying wget. So wget and then followed by the URL, right? So wget http://cdn.csv.net, the URL that we entered before, that will end up downloading the file called shows.csv to our activity1 folder. But let's do something different. Let's say, I have this file shows.csv already in my home folder, and I know it's pretty much exactly the same file as the file that I can download with wget because I literally just downloaded it a few minutes ago. So what if I instead want to have a copy of this file, shows.csv, which lives inside of my home folder, in my activity1 folder? How can I create a copy of this shows.csv file in my activity1 folder? So yeah, the command that I'm going to use is cp for copy. And then how can I say, copy shows.csv from home into the current folder? So I can say something like /shows.csv, because again, shows.csv is in the home folder, and the home folder is the parent folder of my activity1 folder. So dot means parent. So go to the copy the shows.cs file from my parent folder. And how can I say copy this to this folder? What does the current folder or directory mean? What symbol represents that? So I'm going to say copy it right here in this current folder. Dot. So again, dot means the current folder or directory. Dot means the parent folder. So what this will do is copy the file called shows.csv from the parent folder to the current folder. Enter. So this is one way we can get a copy of this file here. If I do ls once more, I can see that the file was copied to my activity1 folder. Now there are different ways. There are other ways to do this. I could have done something like copy ~/shows.csv using the absolute path for shows.csv into the current folder. Or I could have just said, copy it as shows.csv right here. That will also do the same thing. So all of these are the same. All right, so this is how we can copy a file from the parent folder to the current folder. Now, what is the next step? The next step is to print what year did Mr. Robot in to the standard out, which is the terminal. Let's take this step by step. Let's break it down. How do we find Mr. Robot in this file called shows.csv? What command do you use? We can use grep, or we can use igrep, the alias that we created so far earlier. So I'm going to go ahead and use grep this time because just for demonstration. So grep Mr. Robot, and I could have used -i if the case was different, but I know that this case is exactly the same. So I'm just going to grep for Mr. Robot in the file called shows.csv, enter, and that is going to show me the line that matches this search term, which is Mr. Robot. So this is the line that represents the show in the file called shows.csv. Now, what I really want to do is just print this year, which is 1, 2, 3, the third field in this line, right? So what I want to do is feed this output of grep into something as input and just be able to print this year only. How can I do this? So what command do I pipe it into? Yep, so everyone is typing cut. All right, so I'm going to feed this output as input to cut, and then what delimiter should I use with cut? So -d, comma, to specify that the delimiter or the separator of these fields is going to be a comma, because these are, again, comma separated values, right? And then how do I specify which field? The third field. So this is the first field over here, the ID. Second field, which is the title, and then the third field, which is the year. So -F3 to specify that I'd like the third field only from this output. Enter, and that is going to show me 2015. So this is exactly right. Yeah, great job. All right, and then the last step is to find a file called libcs50.a inside of our /user folder. What command do we use to find this file? So literally a command called find. So find space, and then I'd like to search inside of my /user folder, but this could have been any other folder if I wanted to. So find inside of /user the file that has the name libcs50.a. So -name or -name says, here comes the file name that I'd like to search for, libcs50.a, enter, and that's going to take a second and then print out to the terminal user libcs50.a. So this is where the CS50 library lives inside of the CS50 IDE, and we were able to find it using the command called find. Great. So any questions on grep, on cut, on find, on any of the commands that we talked about, or on the activities? What does -d mean? So once again, let's revisit this command. So the first command here is going to find the matches for Mr. Robot in the file called shows.csv, and it's going to output just this line, as we saw here. So we ran this command separately before, and it just outputted this line. We can then pipe this output or feed it as input to the command cut, because we only care about the year, which is the third field, and -d here means that, hey, this line is a comma separated values line, which means the fields in this line are separated by comma. So -d, comma, tells cut that these fields are separated by comma. And -f tells cut that I just care about the third field, which is the year. So 1, 2, 3, which is the year. Why do you not need shows.csv after cut? That is a great question. Because I've already used shows.csv here. And if I run this command again, so if I press up a couple times on my keyboard, this command is going to have output of its own, right? I don't want to deal with the entirety of shows.csv anymore. I just care about this line, the line that I found as a match. So I can just feed the output of this command to the other command, cut as input, and just get what I want. Good question. Any more questions on any of these commands? All right, so before we wrap up, I wanted to share a couple more links with you. So you're definitely more than welcome to use the CS50 IDE for experimenting with some of these tools and any more tools. But the CS50 IDE, which is again a cloud-based environment running Ubuntu Linux, is a more restricted environment. After all, it's designed to be used with a command like with a class like CS50 or other classes as well. If you'd like a more complete version of Linux or a more complete version of Ubuntu, you can go ahead and visit this URL at ubuntu.com/appliance/VM. And this is going to let you download what is called a virtual machine or a VM, where you will be able to essentially run a virtual computer inside of computer. And this virtual computer would be running Ubuntu Linux. So you can experiment with it all that you want without worrying about breaking anything on your Mac or PC, because it's going to be an isolated environment on your computer. So the link once again is ubuntu.com/appliance/VM if you'd like to try this out and experiment. And if you'd like more information about some of the commands that we use today and some more commands and maybe some more examples on these commands, you can go ahead and visit this URL, ubuntu.com/tutorials/command line for beginner, to find a written tutorial for just that, command lines for the beginners. So this is going to include a bunch of commands that we talked about today, and maybe some more commands, maybe some more examples as well, which can be useful if you'd like to take a look at it. All right. And definitely feel free to check out CS50 courses at cs50.edx.org. There's some great content right there, and you can sign up for free and audit these courses for free. So the link again is cs50.edx.org to check out the CS50 courses that we have online, freely available to everyone. And finally, if you don't mind giving us feedback at cs50.ly/feedback, we would greatly appreciate your feedback on this seminar and on the other seminars as well. It would help us improve these seminars in the future. So the link again is cs50.ly/feedback. So please go ahead and provide your feedback there. And if you have any questions, even after this seminar, you can go ahead and visit cs50.ly/seminars/Linux once more. I'm going to put the link in the chat once more. So cs50.ly/seminars/Linux/ed, sorry. So this is going to give you access to the Ed discussion forum, where you can ask questions even after the seminar is over. And we have an amazing group of mentors that can try to help answer as many questions as they can. All right, so thank you, everyone. This was a taste of Linux. I hope you have a great day or night, and we'll see you next time. Thank you.